If I have r of x is equal to 2x times x plus 2 over x minus 1 times x minus 4, I expand to the top and I expand to the bottom. Both of these equations will give me information about the graph. For the top, just to expose what's going on with the y-intercept, I write it as 2x squared plus 4x plus 0, though that's not needed. For my horizontal asymptote, I look at the ratio of the lead coefficients. The horizontal asymptote is the line y equals 2. For vertical asymptotes, I look for when the bottom is 0. That happens at 1 and again at 4. Label x equals 1, x equals 4. My y-intercept will happen when x is 0. When x is 0, y is 0 over 4, which is 0. This is actually unfortunate because I don't get an extra bit of information. My y-intercept is also an x-intercept. I intercept the x-axis when x is 0 or x is a negative 2. So I have 2 vertical, 1 horizontal, and 2 points. To graph, once again I look at behavior, above or below. It has to flatten to the line y equals 2, so it starts above. Every time it hits a root, it is going to change sign. With a single root, it just changes sign once. So positive to negative. Here is another root, the x, so negative to positive. Here's another root, the x minus 1, so it's going to turn negative. Final root is x equals 4, and it turns back positive. Imagine the behavior. It has to start positive, go through this point, go negative, but return here and then finish positive. As it approaches this asymptote, it's got to go to either positive or negative infinity, so it's going to positive infinity. So along the line, through the point, briefly below, and then rising to infinity. In this region, in this stripe, it's negative throughout. It has to start at negative infinity, end at negative infinity. It's going to rise and then fall. I would love to know how high it rises, but you'll have to wait until calculus to find that. As for the final region, it's positive throughout, so I expect it to come from positive infinity and flatten to the line.